From the Brenna Bunker in the quarantine Piedmont of the southeastern U.S., this is Ace Academy, 8th grade science. All right, good morning, 8th grade. It's another fabulous day here in the Brenna Bunker. We have a little bit of a review session today. I'm going over something called the water cycle, which I'm sure you guys have heard of time and time again since 5th grade. So, today's topic again is I can describe the water cycle. I know you guys have heard the water cycle, for tons and tons and tons of times before this, so this should be mostly review. So, let's just start off at the top. So, the water cycle is the continuous movement of water around and through the spheres of the Earth. And when I say spheres, I'm talking like the biosphere, the atmosphere, the terrasphere, all that. So water, whether it's Earth, the atmosphere. So Earth being land, the atmosphere, and then bodies, water, oceans, rivers, lakes, that kind of thing. So it's the continuous cycling and movement of water around through the different spheres of the Earth. So whether it's on land, up in the air, or in some sort of body of water, the water moves in a continuous cycle. Now, we've drawn this for ages as a simple cycle. Let's see. So, start up here with a cloud. And that's what? Condensation. Falls is precipitation. Hits the ground. Runoff. Flows into a body of water of some sort. Let's just call this the ocean. Or it evaporates. To a gas. And it goes back up here. We're going to call this collection. So, collection, evaporation, condensation, precipitation, runoff, collection. We draw it as a cycle. And it's a simple way to think about it. It's not incorrect, but there are so many variables to it that we need to be aware of that can happen. So, just for example, we got a cloud here where it condenses back into this cloud. Clouds don't just stay in one place, they move, right? So say the cloud moves and the temperature changes, and a cloud just isn't a cloud. I mean, it's typically, down here, and it's got a top to it like this. So literally, down here could still be cloud, but then it can evaporate off the top of the cloud. The sun can warm up the cloud enough that that water re-evaporates and turns back into a gas. As it falls as precipitation, the rain can start falling out of the cloud, and as it comes down, the temp changes, and it can re-evaporate before it hits the ground. Sometimes if you go on a weather radar picture on the net, you can see your area is covered by green, which says it should be raining, But yeah, when you walk outside, there's nothing hitting you. So that's rain, falls out of the cloud, hits a warmer layer of air or something that gives it a little more energy, and it re-evaporates before it ever hits the ground. So it's like, the radar thinks it's raining, but in reality, it's not. It's re-evaporating. Now we have runoff, and it can, cause it doesn't just run off into a river and flow into the ocean. It does a couple different things. It infiltrates, which flows through the dirt. It percolates, which is when it goes through permeable rock. Permeable rock is rock that actually has enough holes and passages and airways in it that the water can actually move through the rock. And both of these end up down here with water in underground reservoirs, which we call aquifers. So that's different ways. Now then, aquifers, once the water gets down into the aquifer, it doesn't just stay there. It actually flows around down underground. And then when you have something called a natural spring, everybody's heard of a spring, right? Spring water, that's water literally flowing out of the ground on its own, which all it means is, the land comes down like this, the aquifer is running in a layer of rock that just happens to intersect with this land, and it flows out, and that's where you get a spring, where the water just comes out of the ground. Usually it's just where the land is slightly sloping, intersects the layer of ground where an aquifer or underground water source is, and it just flows out. But that happens, and again, that little spring flow comes out, turns into a small creek, flows into a larger creek, goes back into collection, somewhere, lake, eventually an ocean. And then at any point in this, anytime you see water on the surface of anything, it can evaporate. Then you add in the transpiration of plants. Oh, and they got to get their water from somewhere, right? Because they got roots down the ground. So this, again, infiltrated water sometimes flows into uptake of plants, which then transpires out of their leaves, which plugs back into here. So again, very, very complex in the grand scheme of things. I'll let you stare at it for a second. So runoff infiltrates, which is flowing through dirt, and that's where we end up with, water getting to plant roots. Uptake into plants, plants transpire, which allows the water to be evaporated off of them. It percolates down through permeable rock, flows into aquifers. Aquifers sometimes, when they reach, have natural run-in with the source on the with the surface, and you get a spring, which forms another form of runoff, which again flows into a collection of some sort, whether it be the ocean or the lake, and then you can have evaporation off of that. So again, the water cycle is very complex, but it is what, it's still the basics: evaporation, condensation, precipitation, runoff collection. Still the 5 things, just happens in many, many, many different ways. Got it? If you don't, rewind. Now, how does all this actually happen? Why does this stuff evaporate? Why does stuff evaporate? Evaporation is when water molecules get enough energy that they can turn into a gas. They change phase. When water molecules gain enough energy that they change into a gas. Now, typically when we think about evaporation, it's like, oh, I always use the stove, the pot boiling on the stove. When water boils at 100 degrees Celsius, 212 Fahrenheit. So, that's pretty hot, right? But we're like, well, hey, wait a minute. The surface of that lake isn't 100 degrees Celsius or 212 Fahrenheit. No, it's not. But yet we still get evaporation. Well, how does that happen? Well, evaporation is not just simply when it boils. Evaporation is just when the water molecule that is right there on the surface gains enough energy that it changes into a gas. So now the question is, where does that energy come from? Because we know when we're boiling it, we're supplying the energy on the stove, right? Stove heats up, turns red, all that energy turns into heat. That's heat energy going into the pot. Pot gets hot, heats the water through conduction. Water rises in temperature till it boils and then turns into a gas. But we're not boiling things, and we certainly don't have a big pan, big stove eye up underneath a lake or an ocean to make it boil. So, but again, you got to remember, it's not just boiling that makes water turn into a gas. It's simply when that molecule gets enough energy that it changes phase. So, how does a molecule get enough energy to change into its phase? Oh, where does that energy come from? Oh, Mr. Brenneman, it's the sun. Yes, it is the sun, folks. The sun provides all the energy for the water cycle. Now, how does that energy get here? So, because the sun is here, and the earth is this little speck over here, and in between us, there's nothing. Space. The final frontier. No, wrong story. So, space, nothing. So, between the sun and the earth, there's space. Well, there's actually a couple planets here. There's Venus, and then there's Mercury. But when they're not in the way, there's nothing. Well, it's not really nothing, but it's so little as do we just call it nothing. Remember that. We make a lot of generality, especially in the lower science years. So you gotta kind of just take it as, yes, there is nothing, but actually there is a little bit of something, but it's not enough to be considered anything on a level that we're going to talk about. So we're just going to call it nothing. So how does energy travel from the sun to us over here on the earth through this space of nothing? Well, how does energy travel? We've got three ways, right? We've got conduction, convection, because we're talking about heat, right? Because you walk outside and the sun's out, it's like, ooh, that feels warm, right? So we're talking about heat energy, conduction, convection, and radiation. Conduction requires what? Something to be physically touching. The pot on the stove is being heated by conduction. It is touching the stove. The water is touching the pot. Conduction. Is there touching between here and here? No. There's nothing there. Literally nothing. Can't be conduction. Convection. Convection is when a material is heated up. It rises due to its less dense. Becoming less dense, it rises, and then cooler material flows in down underneath it. It creates a convection cell. Something gets warmed, it rises, the cool things rush in to fill the place where it was. Those beings become warm, they rise. Of course, when they rise, they get cooled off, and it becomes a circular cell. But again, it requires stuff, whether it's a liquid or a gas, but there's no gas or liquid between here and there, so it can't be convection. So we're down to radiation. Radiation is how the energy from the sun travels to us. Now, radiation is not just one thing. I mean, radiation is this big long thing called the electromagnetic spectrum. So, radiation, talk about electromagnetic spectrum. So again, when we talk about energy from the sun, it comes in many different forms. And when we're talking about the energy that it gets absorbed by water to turn it from a liquid to a gas, we're talking two little chunks of the electromagnetic spectrum. One's called visible light. I'll shorten that up to visible light. Invisible light, just like it sounds like, is the stuff that we can see. This is visible light. Those things are light. Different colors, even when we're talking about white. So then you got, on the low end, think about a rainbow. You've got red down here, and on the high end, what's the other side of the rainbow? It's, violet, right? Purple, violet. Now, above the visible light spectrum is the next thing. The next spectrum up of radiation is called ultraviolet, UV. And I'm sure you've heard UV because you've got glasses and UV protection and suntan lotions. And those are the things that keep you from getting skin cancer when you're standing out in the sun for too long. That's the next spectrum of radiation going higher down the path, because as we go this way, energy increases and wavelength wavelength decreases. So the electromagnetic spectrum, as we go from the low end to the high end. So down here is like radio waves and things like that. And up here is cosmic rays, which have so much energy that they literally just go right through the planet. I mean, that's how much energy they have. So the energy increases, the wavelength decreases. Wavelength, a slow wave looks like that. And as the wavelength decreases, we're talking the distance between here and here. That's a shorter wavelength when you do look like that. So the wavelength decreases, energy increases. So we go from visible light, which starts red on the bottom side and violet on the end. Then we go to ultraviolet, and then above that, it's like X-rays. Those things will shoot right through you, all your flesh, but they don't go through the bone. Then you have, gamma rays. And then cosmic rays. Then below this, but I mean X-rays, we know what those are. Gamma rays, that's what makes the Hulk, that's what happened to the Hulk, made him the Hulk. And then, cosmic rays, like I said, are just, random rays coming out of frankly, anywhere out in the cosmos. And they travel, like, literally through the planet. If you run into one of those, a lot of times when people just fall over dead, they probably got hit by a cosmic ray. But anyway, that kind of stuff happens. But then right below visible light is what we call the infrared spectrum, IR. For those of you that play first-person shooters on console games, IR, yes, if you put on the goggles, you can see at night. Night vision typically is seeing in infrared, and they transmit it into a picture. Have anybody seen the old movie Predator, where it's multicolored, the animals and everything else? That's seeing in the infrared. Snakes, pit vipers specifically, see in the infrared. They can sense the heat of their prey animals. That's what allows them to hunt at night. But infrared is immediately below the visible light spectrum. When you see the heating lamps, I've got a heating lamp right here for the snake. And it plugs in, looks like a bulb, but nothing comes out of it that I can see, but I can put my hand up to it and feel the heat. It's definitely something coming out of it. And so it's working in the infrared spectrum. When you go to McDonald's or Burger King and they've got the food that's sitting there, it's already ready, those lamps that are above it, they form a little bit of light because you need some light to be able to see the wrappers. But most of what the energy is coming out of those things is in infrared. That's what keeps them warm, the food warm before you get to take it and go somewhere. Because you're here, I'll hand you the sandwich, but it's cold. You don't want it cold. You want it warm. So it's got infrared lights over the top of it that keep it warm. So this chunk of the spectrum right here, the infrared and the visible light, is the energy from the sun that allows us to be warm. And it's the energy from the sun that heats up those water molecules and allows them to evaporate. So it's this little chunk of the spectrum here of the energy from the sun traveling in a wave as radiation that makes that molecule that's sitting on the surface of a lake, that one little molecule right here on the surface, IR and visible light, makes him, gives him enough energy that he's like, ooh, I'm free. I'm free. And he becomes a gas and then wanders off. Even though the surface of the lake was not 100 degrees Celsius or 212 degrees Fahrenheit and boiling, those molecules right there on the surface receive enough radiation from the sun that they gain enough energy that they make that transition between a liquid to a gas. So they go through their own phase change. So once it breaks free, it's now a gas called water vapor. So just because something the entire mass doesn't have to be boiling or having that temperature for the molecules at the surface of it. That's why when you leave a pan of water outside, even in the spring or in the fall, when it's not exactly that warm, eventually the water just goes away, right? If you keep coming back, it gets lower and lower and lower and lower. So unless an animal, like your dogs, come over and drinking out of it, for the most part, that water is evaporating. Now you leave it in the garage, without opening the garage or an area in the basement or something, yeah, it doesn't evaporate very quickly. But it actually does evaporate eventually. The air gets really dry, and again, there's all the conditions have to be just right for it to evaporate without sun providing it energy. But it gets enough, the surface energy, those molecules on the surface gain enough energy to transform from a liquid to a gas. But that's the energy from the sun that drives the outside water cycle. So radiation from the sun and the infrared and visible light spectrum give enough energy to the molecules of water that are on the surface of the collected body of water, whether it's a lake, a stream, pond, or an ocean, and that molecule becomes energized enough that it transforms from a liquid to a gas and then wanders off as a gas. And then now, at some point, it condenses back into a little tiny droplet. When I say condenses into a droplet, I'm not thinking like a droplet out of a dropper, but I mean like a micro itty bitty droplet. And that's what we see as clouds. And those little droplets in the clouds, as you get more and more of them, they kind of run into each other and they get bigger and bigger and bigger. And eventually, when you get enough of them, those droplets get big enough that eventually they got to come out because of gravity. The air just can't keep floating those droplets away. They become too heavy and they fall out as precipitation. Any questions? All right, so if you got any questions or anything, please hit me on the Google Classroom. This should be mostly review for you guys. Just make sure you remember those vocabulary words: runoff, collection, evaporation, condensation, precipitation, infiltration, percolation, aquifer, and you'll be good. We'll see you next time. On 8th grade science.